Welcome to the deep dive. Today we're getting in something you probably use constantly without even realizing it. It's called Redis.
Yeah, it's one of those foundational pieces, right? Working behind the scenes.
Exactly. It makes so many websites and apps feel incredibly fast and smooth.
Mm.
So our mission today, using Redis, overview, usage, advantages, and alternatives as our guide, is basically to cut through the tech talk
hmm
and figure out, what is Redis really? And why is it so darn fast and, well, versatile?
And it's a great chance to peek behind the curtain, understand what makes your online world so snappy.
Right.
Think of it as a shortcut to understanding some really key internet infrastructure, that aha moment stuff.
Okay, let's unpack this then. What is Redis like at its very core?
Okay, so Redis stands for Remote Dictionary Server. It's fundamentally an open source in-memory data structure store.
In memory.
So
Yeah.
that's the key part. It means it stores data mainly in the computer's RAM, which is super fast. It generally plays three main roles. A really high-performance cache.
Like short-term memory for apps.
Exactly. A database for longer-term storage needs, and also a message broker handling communication between different software parts. It started back in 2009, created by Salvatore Sanfilippo.
So that in-memory part, that's the direct line to its speed, right? Sub-millisecond response times, you hear that figure thrown around.
Absolutely. That's the main driver of its speed.
But how does it do that? What's the magic behind that speed and flexibility?
Well, there are a few things. First, it's written in C, which is known for being very fast, very low level.
Very.
It runs as its own server, optimized for this one job. And crucially, it's easy to talk to. There are client libraries for almost any language you can think of: Java, Python, PHP, JavaScript.
So developers can just plug it in.
Pretty much. And it's not just simple key value storage like some caches. It handles more complex data types directly, things like lists, sets, hashes, sorted sets, even geospatial data.
Geospatial, like maps and location stuff.
Yeah, finding things nearby, that kind of application. This means it can do more work itself without needing other systems to process the data first.
Okay, this is where it gets really interesting for me and probably for you listening. If it's this useful, who's actually using it? Can you give us some big names?
Oh yeah, definitely. You've got huge platforms relying on it. Think Twitter, GitHub, Stack Overflow.
Wow, okay, heavy hitters.
For sure. They use it for stuff like real-time analytics, watching trends, live handling user logins, so session management.
Keeping you logged in.
Exactly.
Yep.
Building leaderboards in games, powering messaging systems between different services. It's often that invisible layer making things feel instant.
You mentioned in-memory again, and my first thought is always, okay, but what if the power goes out or the server crashes? Isn't the data just gone?
That's a really common question. And
Mhm.
no, not necessarily. Redis actually has optional ways to save the data to disk. It's called persistence.
Mhm.
There are two main ways. One is like taking a snapshot, a point-in-time copy of everything in memory. That's called RDB. The other way is like keeping a running log of every single change, every write command. That's the AOF, or append-only file.
So you can choose which safety net you want.
Precisely. Both make sure your data can survive a restart. And for really big applications, there's Redis Cluster that lets you spread the data and the workload across multiple machines.
Scaling out, basically.
Right. Horizontal scaling. It gives you high availability, so if one machine fails, others take over, and it handles splitting the data up automatically, which is called sharding.
And this source mentioned a big community, right? Like 60,000 stars on GitHub, BSD license. That sounds significant.
It absolutely is. That huge active community means Redis is constantly being improved, bugs get fixed quickly, there's tons of documentation and help available online.
So it's reliable. It's not some fringe thing.
Definitely not. It signals a healthy, mature technology you can build on for the long haul. Lots of developers know it too.
Okay, so we know what it is, who uses it. Let's get to the why. Why is Redis so popular? What does this all mean for us using apps every day?
Well, the big why is performance, which translates directly to a better user experience. Redis makes apps faster by caching data that's accessed a lot.
Right.
Think about an online store. Instead of asking the main database for product details every time someone looks at it,
Which could be slow if lots of people are browsing.
exactly. Redis keeps a copy of that product info right there in memory, ready to serve up in like milliseconds. It takes a huge load off the main database or APIs.
Reduces latency, makes things feel responsive.
Precisely. And it works well whether you're mostly reading data or writing a lot of data too.
Yeah, you can really feel it. Those moments when an app just feels instant.
Mm-hmm.
Redis is often part of that story, especially for things like e-commerce checkouts or mobile games, social media feeds,
Yeah.
anywhere that needs low latency and has to handle tons of users.
Totally. It's the secret ingredient for smoothness under pressure.
So it's not just caching then. You mentioned other roles.
Oh, far from it. Caching is maybe the most common use, but its versatility is key. It's used for session stores.
That's the keep me logged in thing again.
That's the one. So you don't have to log in on every single page. It's used for real-time analytics dashboards, tracking things as they happen. It's a powerful message queue.
How does that work? Like sending messages between different parts of an app?
Yeah, using either its publish-subscribe feature, kind of like a broadcast system, or using lists to handle tasks that need to happen, but maybe not right this second. Asynchronous stuff.
Okay.
Gaming leaderboards are a classic use case, using those sorting sets we talked about.
Ah, for ranking players instantly.
Yep. And those geospatial queries, too, finding points of interest near you, that sort of thing.
A lot of different hats for one tool to wear. It sounds almost too good to be true. Are there downsides? Like situations where it's maybe not the best fit or gets complicated?
That's a fair question. No tool is perfect for everything. Because it's in memory, the big one is, well, memory usage.
Right, RAM isn't infinite.
Yeah.
Or cheap.
Exactly. You have to plan your memory needs carefully, especially if you have massive data sets. It can get expensive. And while Redis cluster is great for scaling, it definitely adds complexity. Setting it up and managing it isn't as simple as running a single instance.
A steeper learning curve.
For sure. And in those distributed setups, you might run into something called eventual consistency. During, say, a network glitch where parts of the cluster can't talk to each other properly, different nodes might temporarily have slightly different versions of the data.
So it might take a moment for everything to sync back up.
Right. It usually resolves very quickly once the network is stable, but it's not always instantly consistent across every single node during the partition. It's a trade-off for availability. So yeah, it leads to the question, if Redis is so good, when wouldn't you use it? When is something else better?
Okay, perfect transition. This is really useful for anyone trying to make these choices, understanding the landscape. What are the main alternatives and why pick them instead of Redis sometimes?
Good question. Alternatives pop up because, different problems need different tools, different trade-offs make sense.
Right.
So first up, you often hear about Memcached.
Ah, yes, the other big name in caching.
Exactly. It's also an in-memory key value store, very focused on high-performance caching. Its main advantage is its simplicity. It's super lightweight, very easy to set up, crazy fast sub-millisecond, and scaling it out is straightforward.
There's always a but.
The but is that it only does that simple caching. It doesn't have persistence options, no complex data structures like Redis lists or sets, no built-in messaging or clustering features.
So pure, simple, volatile speed.
That's the niche. Great for basic read-heavy caching where you don't need the data to survive a restart or do fancy operations.
Okay, what else?
Then there are things more tied to specific ecosystems like Cache. It's Java-based, open source, often used within Java applications, maybe with frameworks like Spring or Hibernate.
So embedded more directly.
Yeah, it can be in process or distributed. Its strengths are persistence options. It can store data off heap so it doesn't clog up the main Java memory.
Useful for Java devs.
Very. But the downside is it's really Java-centric. Not the best fit if you have services in multiple languages or need a standalone language-agnostic cache.
Got it. Java world primarily.
Then there's Hazelcast, also Java-based, open source, but it's more of an in-memory data grid. It does distributed caching, but also more complex in-memory processing.
So beyond just storing data.
Right. It has strong, high availability, distributed maps, queues, things like that. The trade-off, it's generally more complex and uses more resources than Redis if all you need is caching or simple messaging.
So for more heavy-duty distributed computing tasks, maybe.
Yeah, think microservices that need shared state and computation close to the data.
Okay, interesting. Any others?
Caffeine is another one worth mentioning, specifically for Java again. It's known for being extremely high performance for local in-memory caching, like within a single application instance, a single JVM.
Just on one machine.
Exactly. Super fast, simple API, clever ways to manage the cache size. But no distribution, no persistence. It's purely for speeding up data access within one Java app.
So very specific use case there.
And finally, you have the really big platforms like Apache Ignite. This is positioned as more of an in-memory computing platform. It does distributed caching, yes, but also handles data processing, even SQL queries against the in-memory data.
SQL on in-memory data.
Yep. It offers strong consistency guarantees, persistence, scalability. But it's a whole different level of complexity to set up and manage. Much heavier than Redis.
So almost like a full database that happens to run in memory.
Kind of, yeah. It's for really data-intensive apps that need that combination of caching, processing, and SQL access, all in memory.
Okay, that's a lot of options.
Yep.
Can you maybe summarize the choice? Like Redis versus Memcached, Redis versus the Java ones.
Sure. So Redis versus Memcached. Redis just does more. More data types, persistence, messaging. Memcached is simpler, maybe slightly faster for basic get sets, but way less flexible. Redis versus catch caffeine. Those Java ones are often better choices if you're only in Java and need tight integration, especially Caffeine for single-node speed or cache for Java persistence options. Redis wins when you need distribution across different services or languages.
Right, the cross-language aspects.
Exactly. And Redis versus Hazelcast Ignite. Hazelcast and Ignite are generally aimed at more complex distributed systems that need integrated processing power alongside the caching or full SQL capabilities like Ignite. They're bigger, more complex beasts. Redis is often simpler and more versatile if your main needs are fast caching, data structures, and messaging, even at scale.
So it really boils down to what your application needs, doesn't it? The complexity, the features, the environment.
Absolutely. Redis, it's a very popular sweet spot. High performance, rich features, persistence options, messaging. It covers a lot of ground effectively, especially in distributed systems or where different programming languages are involved. That's why it's so common.
It really is a versatile tool.
Well, that was quite the deep dive. It's clear Redis is like a Swiss Army knife for data performance. Makes so many things we do online feel instant. It's great to finally understand, what's making things tick behind the scenes. That aha moment you mentioned.
Yeah, and maybe a final thought to leave you with. If you think about Redis and all these alternatives we discussed, it really shows how even simple online actions rely on this whole hidden ecosystem of specialized tools.
Right, different tools for different jobs.
Exactly. So what does that tell you about the future? As we demand information faster and faster, how will these systems for managing and accessing data evolve? It makes you think about all the invisible tech constantly working to keep up, doesn't it?